I cracked myself up. Alright. So, geometry, honors geometry, blessing must raise down after us forget. Honors geometry, Trooper Tide Tuesday, the fine 7th of January, 2020. I know what I'm doing this year. I have 20/20 vision, okay? SWBA, students will be able to classify triangles by sides and angles. Section 5.1, we're talking about triangles, guys. We're into shapes, okay? We're into shapes, okay? We haven't done shapes yet this year, really, have we? Okay? We're getting into what most people would actually consider shapes. What? Did we? Really?
We did not do it.
Like, we're finally getting into shape. Okay?
Getting
So,
in shape, I wish I was in shape.
probably a good idea to write your name. Mayamo Senor Castle.
Yeah, that's what I said.
Okay? Let's see what's right down after. Don't let her in, don't let her see. You're the good girl you're always meant to be.
Oh my God.
Okay. Geometry 5.1. Classifying triangle like we talked about, okay? Triangle is a polygon. Polygon is a fancy word that just means it has many sides. Poly means many, then gon means sides, okay? So polygon just means many sides. So a triangle will be 3-sided polygon, okay? Now we can name this triangle shown at the right, triangle with vertices, A, B, and C. These are vertices of a triangle, the points of a triangle, so to speak, okay? A, B, and C. We can name the triangle, we can say, hey, we can write out the word triangle. And we can call it A, B, C, capital letters for points. Secret, it doesn't matter the order.
Have you ever spelled triangle with triangle?
I don't think so. Triangling? Okay. So,
Sorry, autocorrect.
oh, I have a meme for that. I don't know if I showed you guys that. Anyway, okay. So, triangle ABC, you can name it in any order. You can do BCA, BAC, CAB, BCA, blah, 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 blah. Okay? Or, a lot of times, we also can do small little what? Right, remember, we can do little symbols, okay? So we can do a bit of a triangle, and so we can do that. Triangle ABC, we call it that too, okay? And once again, in any order, okay?
A, B,
Okay.
C,
Okay? So you can draw a little triangle there. Now we can classify triangles in one of two ways. In one of two ways. How many ways, Evan? Two. Very good, okay? So the first way we're going to talk about is classifying triangles by their sides. And we're going to talk about their side lengths.
Why can't they have, why are you classifying them? Why can't they just do themselves?
Goodness gracious. I know it's 2020, okay? Calm down, okay? We're going to classify triangles.
I'm going to be really rude and say that you suck at stapling. Well,
Thanks.
because
Yeah.
Okay, you can restaple it if you want.
how do I do
Okay, cool. Okay. Scalene triangle. A scalene triangle is a triangle that has no congruent sides. Remind me, what's congruent mean? Same side length, right? The same length, okay? The same measure, okay? So a scalene triangle is going to be a triangle where the three sides are all different lengths, okay? The three sides are all different lengths.
Or you can have something expect this or you expect it to
Okay?
I'm saying staple it yourself.
An isosceles triangle. An isosceles triangle is a triangle that has at least two congruent sides. It'll have at least two congruent sides, okay? And in the isosceles triangle, we give some special names to the sides. In an isosceles triangle, we give some special names to the sides, okay? We call the congruent sides legs, and we call the non-congruent sides the base. Now, it says at least two congruent sides, because technically it can also have three, but most often, we just think of it as only having two. Most often, we think of it as only having two, okay? Just like you might see, and you say, okay, well, a square, pretend it's a square, is also a rectangle. But most people are not going to look at that and call it a rectangle. Most people are going to look at that and call it a square, okay? Okay, it's both, okay? So, so similarly, an isosceles could have all three congruent, but we most typically think of it as two. Okay, where we talk about the congruent side legs and the non-congruent side of base. And then we have equilateral triangle, which has three congruent sides. All sides are congruent. Okay, and if you look at the word equilateral, we kind of see what two words in there. Equal and lateral. Equal means same. Lateral means sides. So same side lengths. Okay, so equilateral. Okay, is just a way of saying they're equal length of sides, okay, equal lateral. Okay, like a lateral pass to the side, for example, okay? Or lateral jumps jumping to the side, okay? Okay? Questions on those? What? There is a lateralis muscle.
You're just really short.
I think it's, but yeah, there's also a muscle with the lats.
How does one do this?
So let's look right below this, okay? Not only can we classify triangles by their side lengths, we can also classify them by their angles.
Got you.
Use angles, right? Okay, they're angles. Okay?
Okay, I do that all the time.
Okay?
I don't.
So we have an acute triangle. An acute triangle. We're not just saying it's good looking, okay? We're not saying it's a good looking. We're saying it has 3 acute angles. We're saying it has 3 acute angles. Someone remind me, what's an acute angle?
It's cute.
It's below 90, okay? It's below 90, okay? So we have to say it's going to be between 0 and 90. It's going to be between 0 and 90. So our angle x, angle measure x, would have to be between 0 and 90, right? Bigger than 0, less than 90.
That is the grossest thing I've ever seen.
Thanks, okay? A right triangle. We're not saying it's correct. We're not saying it's on the right side, but we're saying it's a triangle that has 1 right angle. It's a triangle that has 1 right angle. What's the measure of right angle, guys? 90 degrees, okay? And an important thing to note, guys, is the other two angles are acute. The other two angles would then be acute. Okay? Then we have an obtuse triangle, so it's going to have 1 obtuse angle. And we can see the obtuse angle here. Okay? An obtuse angle is between what 2 numbers?
90 and 180.
Yeah, 90 and 180. So it's greater than 90, but it's less than 180 degrees. Okay? And the same thing is true here as well, that the other 2 angles are also acute. The other 2 angles are acute here as well. And then we have equal angular triangles. So how many congruent angles do we think we'll have? 3. Okay. Because equal angular, has the equal angles in that. So we're saying the angles have equal measure. Okay. Does anyone know what the measure of each of those angles would be then? 60, right?
63.
Okay, we'll get into how we actually know that in a moment. Okay. But yeah, I think most of you guys know just from other outside sources what that would be. Okay. Questions on that? Some people. I'm not gonna let the words they walk by. What a distraction. Okay. Don't they know I distract the class enough myself? Continuing on. Classify the following triangles by sides and angles. So we're saying, okay, let's look at this first one here. By side lengths, is this one going to be scalene, isosceles, or equilateral? Scalene, right? We don't see any congruent sides there, okay? So then we say, okay, well, based upon angles, what do we think it is? Acute, right, obtuse, or equiangular? Obtuse, okay? It looks like that top angle is an obtuse angle, and I would agree, okay? So I would say that this triangle is scalene and obtuse, okay? I want you guys to actually go through and do 2, 3, and 4 the same thing, okay? I want you guys to do 2, 3, and 4 the same thing. And once you have those, okay, I want you guys to actually go ahead and raise your hand, okay? And actually, excuse me, I need to draw one thing in here. On number 2, I need to draw this in. Okay? I want to talk about why that would actually be a given on number 2. I drew that in for the angles, okay? Once again, once you have 2, 3, and 4, I want you to raise your hand. Or if you have questions, I want you to raise your hand too. James, are you doing this? Yeah. Okay. I appreciate the look up. If we get you on the right diet, you can zoom in. Very good job, Joe. Let's see how much rings down after let's forget.
Oh, Riley, thank you. First week of getting the license, he takes me on basketball practice, and I just want to start going into the next thing. I'm like,
That's a big
grab
roof.
the wheel, and I turn the pipe back and right. I'm like, Austin, get off the phone. He's like, chill. I'm like,
I know. I was
get off your phone.
Okay. Jocelyn, what'd you have for number 2? I agree completely. It's equilateral and equiangular. Very good.
Yeah, you spoke wrong. Good job.
Thank you.
You're not, are you talking points?
For you? Yes. Okay. Evan, number 3, what would it be?
Scalene and right.
You are right. It would be scaling and right. Okay. Owen, number 4, what would it be?
I don't know how to say that.
Okay. Someone else want to help and say, you want to phone a friend? Okay.
Oh, and I got you. Isosceles.
Yep. And then, well, he can have the other one.
Sorry.
Isosceles. Go ahead. Acute. Very good.
Way to go.
I helped you, Owen.
Okay.
Okay.
Isosceles and acute. Isosceles is spelled weird because it has that weird SC there. Okay. Not to be confused with SK. Let's see what's written. I don't have those. Okay. Question. Oh, sorry. Take it back. Okay. Yes.
Is it, okay. Is there like you know English? No. Like a certain order it has to be. Or, like you have to do that one on.
Do I have to say isosceles before acute?
Yeah.
Technically no.
Would you label it?
No, yeah, it technically would.
No, because I didn't do that.
I just had it here like this because I said size was A. So like typically if I said label by both, I wouldn't care. But here if I said this way, it just makes it easier to read.
What if I did B then A? Stop
I
it.
mean that's cool. I just want you guys to read row B so that way I can know. Does that make sense? Does that make sense?
Sure.
Yeah.
Sure.
Okay. Let's go to the next one. Next page. Okay. We're gonna sketch some examples here. Okay? So I want to know the types of triangles that we're describing. I want you guys to see if we can sketch them, okay? So we have 4 different types here. We have an isosceles right, an obtuse scalene, a right equilateral, and an acute isosceles, okay? So we don't really care if the angle or the side part comes first, because some of those are kind of mixed up. We don't really care which one first, so which was right is the question, okay? So I want you guys to mark the triangle to indicate whatever information is known. For example, like on the previous 4, this is isosceles, so we had to mark these 2 sides were congruent. On the equiangular, we had to mark all 3 angles were congruent. We have to mark the information, like this is a right triangle, we have to mark a right angle on there. Okay? We have to mark whatever information is known. If the triangle cannot be drawn, we have to write not possible. Okay? There's one of these that is not possible. I want you guys to try these 4, okay? And don't raise your hand when you're done, actually. You guys can just chill when you're done, okay? But I want you guys to work on these 4.
What if there's all of them are not possible? They're not because I can't write.
I believe. I also believe in carbon dioxide. Five of them, yes. Teriyaki, Mongolian sunbird, black pepper, shoyu, honey mustard, and then what was the other one?
Oh my god. That's better. Dope.
that video.
In the class.
That's great. There we
Ow.
go. It's very artistic.
Some of them are right.
Yeah, there's
What?
one that can
Some
use
of them are
for
right.
something more than that.
Tell me which one.
You act like I listen.
Cool.
Sarah, do you want to come up and do the first one?
Yes.
No.
Oh, sucker. Can I do one of them?
Now, is it possible that this one might look different than what you have?
Yes.
Yeah, and is it possible that both are correct?
Yes.
Yeah.
No.
Okay. We'll talk about what things have to be there.
That's off.
I'm sweaty. My hands are a bit sweaty.
Oh, I'm stupid. Okay.
Okay. Explain.
Okay, so you have the right angle here, 90 degrees, and these sides are the same. There's two congruent sides.
Very good. And we had to mark those sides congruent, okay? Now, what would have to be the same here, guys? That's what Sarah did. Very good. Okay, top on the back, okay? Is that the two congruent sides have to be touching the right angle. Those two congruent sides have to be touching that right angle, okay? Peyton, can I have you do number 2?
I don't know, do I have it right?
It looks like it. I mean, that looks good to me.
First, I was gonna put my gum in your hand, but
That would be the worst.
it's very off, by the way.
Sure. Okay, explain it.
Scaling means it has no congruent sides.
Mhm.
Those are congruent, and then that's all this is.
Very good. And now, one might argue, okay, some people, some of you in here might want to argue too because you're nitpicky. I get it. Feel like grade, okay. Might want to say, well, those top two might look like they're the same, right? That's something grade could say. Okay. But they're not marked. Very good. So we don't know that they are, so we assume they're not. Okay, so that's an obtuse scalene triangle. Very good. Okay.
You know, in the ACT they have to drive the main proportion, so technically,
They don't have to draw to scale.
that's what.
Well, they said they do have to. In the ACT, it's super not drawn to scale.
Like, no, as if. I'll explain. I'll
Okay.
write a good explanation.
Okay, cool beans. Okay.
My brain.
Bradley, you want to do number 3?
I guess so.
Okay.
I can't do this, I gotta go.
Number 3 is pretty hard. I have one. Thank you. I appreciate your willingness.
It looks like you're struggling.
Good luck. I was. This was a struggle bus. All of it. Okay, explain. Why is that not possible?
Just can't do it.
You can't do it. I simply can't. Okay? Why can't it be both right and equilateral?
Cause like it's just not possible.
Okay, Alyssa?
Because if you have both
Yes.
sides,
You go right.
like two right angles are equal, then the other
Oh,
one.
I have read what that means.
Say it again.
If the two
Okay.
angles that make the right angle are the same, then the last one will connect.
Alright? So you're saying for them to be equilateral also has to be all the same angle? Is that what you're trying to say too? Or no? What are you trying to say?
No, like the other angle has to be longer than the other two.
One side?
Yeah.
Has to be longer than the two? Okay? So she's saying for a right triangle, one side has to be longer than the other two, which is absolutely correct. Call it the hypotenuse. Okay? And so if one side is longer than the other two in this right triangle, we can't have one side being longer and yet the other two meet. Because if it's longer, that wouldn't end up working. Okay? You can't have them longer and the same. You can't be both. Okay? That's exactly right. Also for an equilateral triangle, is there actually end up being 60 degrees each. And they're 60 degrees each, can't be 90 degrees each. Okay? Taylor, do you want to do the fourth one?
Yes, hold on, make it
Oh, rolling back. I haven't seen that since like 4th grade.
We don't practice.
Okay. That was cool, but okay.
There's some dope wheels.
Yeah.
Do you ever actually
Well, this is
roll
the
it?
new one.
I have to, I can't hear it.
Who is this one?
I'm not watching.
Taylor, you should, Jack.
I noticed the back that.
The same group.
Oh, yeah. You know, you have one for all of them?
No, you have to like
Explain it, Taylor. What do you do from there?
An eye has to be only two congruent sides,
Isosceles has to be two
and a
different
cube
sides.
has to have both.
And they have all acute angles. Very good. Okay. I agree with that. Anyone have any questions on these?
No.
Thank you, Lydia. Let's continue on. Okay. We're gonna talk about the triangle sum theorem. Guys, I really think you probably already know this for the most part. Maybe a couple of you don't, that's fine, okay, because we're learning it as if you don't. But I'm guessing a lot of you already know this, okay? The sum of the measures of a triangle, the sum of the measures of the interior measures of the triangle, so we have the measures interior and exterior, inside out, okay? What's the sum of all those three measures? 180 degrees. Okay. That's all the triangle sum theorem says. It's saying, hey, if we had all three angles up, we get 180 degrees. So the measure of angle A, B, and C would be what if we had them together? 180 degrees. If we had all three angles together. Okay? That's all that's saying. So if we have this example here, right, directly to the right of it, find the missing measure and classify each triangle. So if we have measure angle A, measure angle B, could we find measure angle C? How? Add and subtract 180, right? Okay. So what would 42 plus 52 be?
94.
94 degrees, okay? And then we take 180 degrees, subtract the 94, borrow, right? 10 minus 4 is 6, borrow again, 17 minus 9 is 8. So measure angle C is 86 degrees. So based upon these three angles, do we have an acute, a right, an obtuse, or an equal angular? Acute, right? All three angles are acute, and they're not the same. Okay? Questions on that first one? I'll let you guys do the second one. Okay? When you don't have questions, raise your hand. When you don't have questions, raise your hand. Yep, one check.
Yeah. Taylor. No. Carly. No.
Okay.
Yes, here we go.
I don't know. I'm just happy. I'm really hoping it doesn't hit me. Riley.
You buy their
Yeah.
Do we have all the albums? I thought you said the herbs.
Can I have one sip?
Why not?
She knows I'm 5 minutes. Why can't I have one sip? What?
Oh, it's where my favorite is rain. In case you're wondering.
I got it right.
Hey. This is why you're my favorite. No. Wow. That's something that. It sounds like Owen Wilson. Oh, and Rowan. Owen. Hey, hey, Kayla, explain what you did. Everyone knows it off, but Kayla explains what she did.
Hey, Mr. Possible. I can hear you all the way down the hall.
Good.
Can you shut the door? That's fine.
Very good. So we had 45, 40 up to 90. 180 minus 90 was 90. Right triangle. Awesome. Yo, good stuff. Okay?
Shut the door.
Yeah. For
At
real.
least you said, can you?
The wind blows on.
Okay. So we're gonna learn about this thing. It's called a corollary.
Who?
A core.
I
Wait,
hear all
isn't
of
that?
these words are
Okay, I just want to say I'm pretty sure I've heard that word on Grey's Anatomy, so.
Maybe. Corollary just means they're kind of related. Okay.
Oh, I
So-
already got your shepherd. Hold on, wait.
You have the eraser.
Oh my god.
Wait, which one?
Yeah, let me borrow Kevin.
I said Dr.
Do I
Shep.
have time to erase it?
Okay. A corollary to a theorem, guys. Listen up, listen up, listen up.
I'm messed up.
Okay. Corollary to a theorem is a statement that may be proved easily using a theorem or it follows directly from a theorem, okay? So corollary just means it follows directly from something or something leads to something else, okay? So corollary to a theorem just means it follows directly from it. So we have the triangle sum theorem, and then we have a corollary to the triangle sum theorem, meaning it just follows straight from it, okay? And I just wanted to explain what the word corollary means because we talked about postulas, what are those? What are those, okay? We talked about theorems, talked about definitions, okay? We talked about all these things. Now we're going to have a corollary. So corollary to triangle sum theorem, this says that the acute angles of a right triangle, okay, we have a right triangle, the other two have to be acute, okay? Those acute angles are going to be complementary. The acute angles are going to be complementary. So here, in this triangle, ABC, if angle C is a right angle, what do angle A and angle B have to add up to? 90 degrees. Well, let's think about it this way, guys. What are all three of these angles going to add up to? 180. Well, if we know one of them is 90, we can subtract that, and so the other two have to add up to 90 every time. So I might look at that and be like, well, why do we even say that? That's just so straightforward. Like, of course that's going to be 90. Duh, right? Okay? So that's why it's a corollary. It's because it means it is that straightforward for us. Okay? It's not like we had to go like really deep in depth on something. We just had to say, oh, sum 180, subtract 90, cool beans. Okay? Questions on that? Cool beans. Okay? So let's look at this example here, okay? So I want you guys in this triangle here, okay, with this angle being 2x minus 40, this angle being x plus 20, and this angle being x, I want you guys to solve for x and find each of the angle measures and use that to classify the triangle. So who has an idea on what we can do to set this one up? What could we do to set this one up, okay? Graydon, what are you thinking?
Add them all together.
Add them all together, okay, so x plus
X plus X plus 2X plus 20.
x plus x plus 20 plus 2x minus 40, and then you said add up to what?
180.
Why 180?
Because that's a triangle.
Because that's the sum of all three measures of a triangle. Yeah, the sum of all the interior angles of a triangle, okay? So if we add up all three interior angles, we get 180. So let's add up the interior angles. It might help you to think about it this way. This is the first angle, this is the second angle, and this is the third angle, okay, in those parentheses. Okay, we don't need the parentheses there, okay, so that might help you think of it as saying, oh, we're adding the three angles together. Okay, can you guys solve this equation? Yes, use your algebra skills to solve this equation. Okay, so you'll find x, and then I want you to find all three angles and see what kind of triangle this is. Okay, so I want you to find x from this equation, find all three angles, and then I want you guys to classify the triangle.
I feel like I got a rock.
Oh, no.
Nards. Can I have a sip of your mouth, monster?
This is the first day.
No, because you're gonna ask me, right?
But you're
Check this out.
No. No, you will not do it.
Riley, yeah, it's a good look.
If she gives me a lunch.
you traitor. Thank you.
Your hair was like all like your hair was like
Those
guilty
are
of shit.
possible.
I was like,
Did you ever wonder how to get people to take advantage of your
oh,
thing?
You like it?
It's just- I'm gonna cut my nails.
It's my Star Songs.
Oh, nice.
They look fuzzy, are they?
No.
Okay. I think they're so cool.
I got a lot of socks though. So
Yeah?
I did right there.
What's 70 plus 30? 130, so 30 plus 50.
What?
Oh, no.
I might have done it once.
Santa Cruz.
I might have done it once and then you never let it go and I was like, oh, this is your thing now. I was like, you're not Sarah.
DR.
I like that you're being creative.
UISE.
No.
So, let's see what's written down after, let's forget.
Oh.
Okay.
Why do you do it so aggressive?
Okay, so let's combine like terms. X plus 2x is 4x. 20 plus negative 40 is negative 20, and then equals 180. Add 20 to both sides. 4x is equal to 200. Divide by 4 on both sides, and x is equal to 50. So you know this angle is 50 degrees. So from here we can say x plus 20, aka 50 plus 20 is what?
70.
Awesome. And this one ends up being
60.
60, okay? We can take 2 times 50 minus 40, so 100 minus 40 is equal to 60, okay? And so what kind of triangle is this? It's a cute triangle. It's a good looking one, right? As you walk by and thought, hey, this one's good looking, okay? See? She owns up to it, okay? Thanks for putting that way. I appreciate it, okay? Any questions on that one, guys? Okay, dope. Okay, let's go to this next page here, okay? This is our last page of the day.
Yes.
Okay? So we have 2 types of angles for a triangle, okay? We talked about how we had interior and exterior. So let's talk about the interior one more time here real quick, okay? The interior angles are angles inside a triangle. So even if we extend the sides here, so we kind of look here, and I can say, like, this is the triangle, right? That's the triangle there, but we extended the sides. We said, hey, let's pretend the sides keep going as lines, okay? Well, those 3 angles inside are still going to be the interior. Those 3 angles on the inside are still going to be the interior, okay? So we have like this angle, and this angle are still going to be the interior. And so I'm just coloring them just so we know which ones we're talking about. And what did we say we know is true about the interior angles? They add up to 180, right? Okay. Okay, they add up to 180 degrees. Okay. So then we also have the exterior angles. Okay, we have exterior angles of a triangle too. Okay. So once again, we took our triangle, and we extended the sides. We took our triangle and we extended the sides. Okay. Now these are the angles that form linear pairs with the interior angles. They form linear pairs with the exterior angle. So if we start with this top angle, okay? Start with this top angle. Here's the interior. So here is the exterior. It forms a linear pair with that. Remember, if we recall, a linear pair is adjacent and supplementary. So they touch, they have the same vertex, same side, and they add up to 180. Okay, they're supplementary. Okay? So this would be an exterior angle. Are there other exterior angles here too? Yeah, okay, down for this interior angle, okay, it could actually have 2 different exterior angles. It could have one over here or one over here. Why is this one where my pen's at right now not an exterior angle? It doesn't make a linear pair. Okay, it doesn't have to 180, they're not adjacent, okay? It'd actually be what kind of angle? Vertical angle, very good, okay? It'd actually be a vertical angle, okay? And instead of being supplementary, vertical angles are
Vertical.
congruent. Very good. Okay. And I heard someone say congruent. So either of these could be an exterior angle here. So how many exterior angles could we have over on this interior angle? 2. Okay. Once again, the one on the far left is what kind of angle? Not because it's a vertical
Linear.
angle. Okay. So it's not a linear pair. Okay. So if we take these angles, okay, and let's actually, I'm going to back up to this, but I don't need you guys to, okay? I don't need you guys to, okay? Actually, yeah, I don't need you guys to do that, Actually, I suppose it doesn't matter. Yeah, anyway, so if we were to take one exterior angle from each vertex, so if we take 3 different exterior angles, so we say like these are like the same exterior angle because they're gonna have the same measure. Okay. If we take an exterior angle from each vertex, if we take an exterior angle from each vertex, okay, we can add them together. And fun fact, guys, they're gonna add to 360 degrees.
Whoa.
Right.
Okay, 100% of the time they're gonna add to 360 degrees. So if I take those measures we had a moment ago, okay, we had 50 degrees here, we had 70 degrees here, and we had 60 degrees here. Okay, that's what we had in the triangle we just solved on the last page. Okay, when I went around when we checked them. Okay, those are the ones those are the measures we had. So what would that make this angle right here? This is 70. This is 110. What would this be? 130. And what would this be? 120. If we add those up, 110, 130, 120. And we say, well, zeros. 1 plus 3 plus 2, that's 6. 1 plus 1 plus 1 is 3. 360 degrees. And I don't care what 3 angles you have on the inside. If you take the exterior angles and you take one exterior angle on each vertex, you'll always have them add up to 360. Now, would it have worked if we had taken like 110 and 110 and 130? No. You have to take one at each vertex for this to work, okay? So you have to take different exterior angles. You can't take 2 at the same one. Is that your question, Alyssa? Dope, okay? Love that you were asking that. Right, that you look confused.
How did you get 110, 130,
Okay, so we said if this interior angle is 70, what's the exterior angle that makes a linear pair with it?
Well,
110.
oh,
And we
I
did the
get
same
it
thing
now.
here and same thing there. Great question. Thank you for asking, okay? I don't want you just to stay confused forever. I want you to understand. Okay? Dope,
Okay.
okay? Any other questions on this?
You
Okay.
just closed it right on that portion.
So awkward. I'm so sorry. Oh, that's not mine. You want to trade me?
Thank you.
Yeah. Hey, thank you. High five. Nice. Okay. Have a great day, guys.
Right as he went to open it.
Yeah, no, that's so awkward. I feel bad. Okay. So, I know. Okay. I didn't mean to. Okay. So, if you take one exterior angle at each vertex, okay, they end up adding to 360 always, 100% of the time. Guarantee it. So interior angles add up to what?
180.
Interior angles up to 180. Exterior angles add up to 360. That was good. Okay. We'll pretend that didn't happen, Sarah. Okay. So that's our exterior angle theorem. Okay. That's the exterior angle theorem there. Okay. Now we also have excuse me. That's just an exterior angles fact. Let's see what's going on. I swear, I know I heard one. I don't know who it was, but I know I heard it. Exterior angle theorem. The measure of an exterior angle, okay, the measure of an exterior angle of a triangle. So here, if it, like angle 1, the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 remote interior angles.
Wow.
Okay, so we're saying the measure of an exterior angle is going to be equal to the sum of the measure of the 2 remote interior angles. Wait, remote interior, we haven't learned that yet. We learned interior angles. Well, remote, let's think about this, okay? A remote, when do you guys hear the word remote? Like a TV or a controller of some sort, okay? Now, when you're using a remote controller, do you have to be right next to the thing? No, you're going to be a little bit away. That's what remote means. Remote means you're a little bit away from it, okay? So remote means you're away from it. You don't have to be right next to the TV to use a remote controller, okay? You can be away from it. That's the whole point of it, okay? So remote interior angles, so are the 2 angles away from it. So angle 1, if this is the exterior angle, what would the 2 remote interior angles be? A and B. A and B would be our 2 remote interior angles, because they're the ones away from it. C wouldn't be, but A and B are the ones away from it. So what we're saying here is the measure of an exterior angle, angle 1, would be the sum of the remote interior angles. A and B. And we can actually see why this is in a moment. We can actually see why this is the case, okay? And that's what it says here. Remote interior angle is an interior angle not adjacent to the exterior. So if this is the exterior over here, okay, our remote interior would be those two not touching. Okay, that's just what we had said on the other part too there. And we can actually take a look and analyze why this is. Well, if we think this exterior angle has to be supplementary with this, this interior angle has to be supplementary with the exterior angle, correct? They make a linear pair. So supplementary means they have to add up to what? 180. So these have to add up to 180, don't they?
Yeah.
Well, what else is true? Well, this angle, this interior angle, if we add it to the other two interior angles, what does it have to be? 180. So either way, whether this interior angle adds up with the exterior or with the other two interior, it has to add up to 180. So if they both have to add up to 180, we can say it doesn't matter whether we add this or this. So we're saying, hey, look, 60 plus 120, that's 180. But also, if we take 60 and we add the other two angles, so 60 plus, let's just say, angle A plus measure of angle B, that also has to equal 180. Well, we can see then that angle A and angle B would have to add up to be the same thing. Angle A and angle B would have to add up to be whatever this was. Because it's like you replace 120 with the measure of these two added together. Does that make any sense? So you're giving me a no? Okay. Okay. Does anyone have any question on that? Because I can explain it differently if we need. But I want to explain it 5 different ways if you guys don't need that. That's annoying. Okay. So, we're going to use that. So, wow, this did not come across well.
Yeah,
Let's try
no,
this.
I can't read it.
So, this is 145. This is 145. That didn't help either. Let me try that again. Round 2. Okay. So this is 145 degrees. This is supposed to be 2z. And this is supposed to be, I believe that's, I'm not even sure now. 5z minus 2. Doesn't matter. Just change it up. Okay. So this is 145 degrees out here. And these two interiors are 2z and 5z minus 2, which should be 5z minus 2 degrees and 2z degrees. Okay.
Yeah, there's like a sudden
Okay.
Maybe
So-
Oh, it does.
So we have an exterior angle and two interior angles. There's a couple of different ways we could solve this, and they're both perfectly fine. Does anyone have any ideas on how we can solve this? Okay, Sarah, what do you think?
Add them all together and then set them equal to 180. Like, put them in an equation.
Okay, so you're saying add 145 plus 5z minus 2 plus 2z equals 180. That's what you're saying?
Yeah.
Okay. Does anyone either agree or disagree with that?
I disagree
Okay, why do you disagree, Brady?
because that would be way too high. 145 is supposed to equal A and B together
Okay, 145 is supposed to equal A and B together. How do you know that?
because that's the rule. That's remote interior angles.
Yeah, that's the exterior angles here because these are remote interior and this is an exterior. Now, what would have made this work if this was not an exterior angle, but if this was an interior, that would have worked. Okay, but that doesn't quite work. So we can do 145 equals, what did you say, Graydon?
2z plus 5z.
If we add them up, okay, if we add the two remote interior and set them equal to the exterior. Okay, if we add the two remote interior and set them equal to the exterior, that works. Okay, I want you guys to go ahead and solve this. And then we're finding the measure of angle B. Okay, so grand scheme, we're finding the measure of angle B. You actually don't have to raise your hand this time. I know. Okay, 145 is equal to 7z minus 2. 7z minus 2. add 2, add 2. 147 is equal to 7z, not to be confused with Sprechen Z, which is speak in German. So 7 ends up being, or z ends up being equal to what? Anyone? Plug that into angle B. 5 times any1 minus 2. 105 minus 2. Measure angle B does equal 103. Thank you. Questions on that? Okay. Now, if you're more comfortable, does anyone know a different way we could have solved this? Okay, Green, what are you thinking?
You could have found C.
You could have found angle C, right? Yeah, I could say, hey, these out at 180. 180 minus 145. This is going to equal 35 degrees. Okay. Add 35 plus 5z minus 2 plus 2z equal 180. If you're more comfortable with that, you can do that. That's also okay. These all 3 angles interior have to add up to 180. So you could have done that if you're more comfortable. Okay. On this angle B, on letter B, we have 3x minus 8 degrees. We have x plus 2 degrees. And we have a right angle. I want to give everyone a chance to set this one up on how you think you might do this. Okay, we're going to set up, but I'm not actually going to make you solve. Okay, I'm going to set up, but I'm not going to make you solve. Okay, yes. Stretching. Question.
That's a right angle, right?
Yes. Right, that is a right angle. Rachel, how do we set this up?
I put 3x minus 8 equals x plus 2.
I'd agree with that 100%. 3x minus 8 is equal to x plus 2 plus 90. The exterior equals the sum of the 2 remote interior. Very good. Okay. So even though we aren't told this is 90, we know a right angle is 90. Questions on that setup?
Yeah, I'm confused.
Okay. What's up, confused, Mr. Gossel?
Oh, is it because it's on the inside of it?
Yep, because the right angle's on the inside. Yeah. So we know this is exterior and these 2 are interior. So by using this,
Oh,
we get that. Does that make more sense?
okay. Yeah.
Dank, okay? Now if we look down at the bottom one there, it starts saying some stuff about having it twice the measure. Okay? So we're saying, hey, if this is twice the measure, so if C, so on letter C, if the interior angle drawn measures, let me read that again. If the exterior angle drawn measures 150 degrees, and measure angle D is twice the measure of angle E, we're trying to say what would this end up being. Okay, I want to give you guys a second to see if you can set this one up correctly. Don't have to solve. I want to see if you can set this one up correctly here.
I definitely do.
This is a bit of you can try. Owen, what did you do?
I put 2x plus x equals
2x plus x equals what?
50.
150. Where did you get 2x and x from?
It says it's twice the amount of d,
Okay, so what did you call x?
just the angle of
Angle E, and then 2x was
d.
D. We know angle D is twice the measure angle E. We don't know either of them yet. We can call them anything. So Owen called him x. So if we call it EX, well, D is twice that, so 2x. Well, now we know the sum of the 2 remote interior angles, x plus 2x or 2x plus x, is equal to the exterior. So then we can solve from there, find x is 50, so on and so forth. Questions on that?
We're done.
Okay, we're done. Now guys, I know this is stapled together, but I have like a chunk of don't do's. Okay, like I have a chunk of them. Chunk.
Can we just do one here at the end?
What?
Let's just have don't do one.
Oh, I thought you said you wanted to do all of them. I was gonna be like, well, you can, Graydon.
No, no.
You always have that option. No, you do always have that option. Oh, it is.
How about you make him do that?
I can make it not an option for you. And I can just make it the option.
I'll be quiet.
Good, about time. I wish you would have sent this email last year.
I'm live, by the way.
Okay. Don't do, and you guys can cross these out. You guys can cross these out. Numbers 9, 12, 14, 21, 23, 24, 26, 28, and 31. I told you guys it was a chunk. So 9, 12, 14, 91, 23, 24, 26, 28, and 31. What's up?
Not weird.
I
I have to go to the rock.
it is.
What made you decide on these ones?
Some of them I didn't like the way they worked out. Some of them I felt like we had enough that were similar to it anyway, so I just kind of chose one of them. So yeah, that's what I ended up deciding. I just look at like, oh, we already did a lot of those. This might be overkill. Take too long.
B.
So yeah. I just actually put them all on the dartboard randomly because, and I was like, well, there's no don't do's because I missed all of the boards. So. I feel like I low-key trashed myself during that.
That was pretty good.
I'm so good at burning, I don't even stop to burn myself. I don't even stop from burning myself, rather. Oof. Yeah, that was a botch.
Pretty sure I have low